Hello, and welcome back to AP Environmental Science. Today's conversation is going to be about mining and minerals. And this is something that we've talked about a little bit before when we talked about coal, because coal is, of course, mined. But in that conversation, we focused on subsurface mining. And today what we want to do is broaden that conversation into types of minerals and other types of mining besides subsurface, and then, of course, the environmental impact of those. Okay, so first of all, what is a mineral? Well, it turns out that there are lots of definitions of mineral. It kind of depends on who you ask. Geologists sometimes have one definition, whereas mining engineers have another. But basically, when we're talking about a mineral, it's some naturally occurring inorganic substance that has a definite, predictable chemical composition and physical property. Now, there are some exceptions to that, like coal, for instance, is not inorganic. So the definition includes substances that are considered useful. They may not fit this actual definition of a mineral right here, but they will be included in minerals for mining. Okay, and so here are some of the things that are mined that are in your house. And so when you start looking at all of these things are all coming out of the ground, right? And so a good portion of your life is based on mining. So the first thing that usually comes to mind besides coal, right, when you're mining are gems. The beautiful jewelry quality things that we love so much that are so expensive. But this is really only a small portion of mining. Many of the things that we get are things that we don't even think about that are non-metal minerals, and these are going to be elements or compounds that are useful, but not metallic, right? And we'll talk about metallic in just a second. But here's some of them. Here's coal, of course. Now, this is inorganic. The rest of these this is organic. The rest of these are inorganic. But here's a nice big rock face that's marble. Salt, talcum powder, baby powder, and sulfur are all things that are mined. And then, of course, metals. We always think about metals, copper mines, iron mine, right, that sort of thing. Metals are elements or alloys, and we'll talk about alloy in just a second, that's useful because it can be stretched into wires, flattened into sheets, or hammered or molded without breaking. That means it is malleable, right? That characteristic is malleability. Okay, now minerals are typically found in ores, and we've talked about this a little bit, but an ore is a rock that contains the metal, and sometimes you'll see this nice vein where you can actually see, oh, look at that shiny thing, it's metal. And sometimes it's going to come in the form of, say, a compound, right? A lot of times there'll be oxides or whatever, and there are lots of different ones of those. And so when you start looking at metals here, these are the ores they come in, and these are going to have a chemical formula that has other things in it, but it will also have this. So I highly recommend that you know at least 3 of these. Know at least 3 of the ores and the metal that you get from them. Okay, so an alloy is not one metal, but it's 2 or more metals that are mixed together. It doesn't always have to be a metal. Actually, in some cases, you can use carbon. Steel, for instance, has carbon, and it's iron and carbon. But this strengthens the metal or makes it more resistant or gives it a higher boiling point, whatever, melting point in that case. Yeah, not boiling, sorry, melting. But it's something that allows that to be more useful. And so here are the really common ones that you're going to find in your life. Bronze, brass, steel, stainless steel, coin metal, right? So this is going to be your pennies and your nickels, sterling silver, jewelry, and then karat gold, right? And remember, gold is really soft, and so you have to add something to it. And the alloy is going to depend on the color, right? Whatever color you want in the outcome. So here's gold. You've got yellow gold, rose gold, and white gold. And so that's going to depend on what you put in it. Here's a nice steel, right? Here's some bronze. There's some brass, stainless steel, coins, that sort of thing. Okay, so which of the following is considered a mineral resource? Well, coal is a mineral resource, even though it's organic. Sand is definitely a mineral resource, and that gets quarried. And quarried is a type of surface mining. Aluminum, that's a metal. That would be considered a mineral resource. Barium is an element that is not a metal, and so that is going to be your non-mineral. Okay, so how do we mine? We've already talked about subsurface mining, so we can see our coal notes on that one. Surface mining comes in 3 big categories: open pit, strip mining, and mountaintop removal. And so in the United States, about 90% of mineral resources are extracted by surface mining, subsurface mining, seabed mining, or mineral harvesting. Mineral harvesting would be all these things. But surface mining is actually the answer. We do have some subsurface mines, but the majority of things are close enough to the surface that we can just dig them out. So let's talk a little bit about surface mines. These things can get really, really big, by the way. Open pits are the oldest type of mine. You just dig a giant hole, right? And so you remove everything, the ore, the sand, the gravel, the stone, whatever's there, and then you process it to get whatever you want out of it. Now the trick is, a lot of times you'll get toxic groundwater accumulating at the bottom, and we'll talk about that in just a minute. Now, area strip mining is where you take away strips of overburden, get the mineral out, and then you put it back in these piles called spoil banks. These spoil banks are loosely packed, which means they're highly erodible, and so you get massive amounts of erosion here, right? Now, contour strip mining is where you cut into the side of a hill, okay? And this is really used only on hilly or mountainous terrain, and it works really well if you restore it. Now, if you don't restore it, what you're going to get are these things called high walls. And high walls are erodible banks, and so that is problematic. But if you just fill this back in, right, you can recontour the hill, and it works out really, really well. Okay, now mountaintop removal is kind of the opposite of digging a giant hole. It is cutting the top off a mountain, you start on the top, and you just dig your way down. And I think you can see the problems with that. The other thing, too, is that you dump down the mountain, you're going to have a lot of stuff that ends up being dumped into streams and valleys below. Okay, so you can also dredge, and this is underwater mining. Now, in dredging, you have to dig out the bottom of whatever it is, a river, lake, ocean. Usually it's going to be lake, and a lot of times it's ocean. Now, the problem with this is it really disturbs the sediment, destroys the benthic community, it clouds the water, it can release pollutants into the water, heavy metals, whatever. Now, as a side note, it's also used just for deepening water, not necessarily mining. Okay, so which of the following is a possible environmental effect of seabed mining? This is to see if you were just paying attention. And also to think about how large the ocean is. So obviously the answer is it stirs up ocean sediments because you're digging into the ocean. And you could think that, oh, hey, maybe that might affect the salinity because there might be salts in the rocks, stuff like that. But you're talking about a huge body of water that is connected. And so you can't have just an area that's going to change like that because it's all flowing together. And it's far too big a system. Same reason you're not going to get temperature changes. Also, there's no reason for that to happen. And you're not really going to affect the migration patterns of whales or any other animals because you don't have large barriers. They can actually just swim around the rigs. Okay, now when we talk about mining, you also have to talk about not just extraction, but also processing. And so you have all of these things that have to happen. You start with the mining, right? Then you get whatever it is you want. You have to separate out what you want from the rest of the ore, right? So you've got your ore, you got to separate it out. If it's a metal, it has to be smelted, right? And that means that you melt it and you get all the impurities out, and then you may want to do whatever you want with it. You may have to temper it if it's iron. And then, or you have to make an alloy, so you're mixing it, and then you convert it into some sort of product. When that product's usable life is over, it gets discarded, and there are numbers of ways of that can happen. But you could stop this waste issue and come all the way back around to recycling, and so that's one of the things we're also going to talk about. But this is a huge use of resources. It's a huge impact on the environment, okay? And then here's just an overview of surface mines, things that you have. You can have chemicals, toxic things percolate into the groundwater. Again, leaching of toxic metals or other compounds from the spoil, right? This is just from drainage. This is from the actual spoil banks. You've got all of this runoff, all this sedimentation. The leaching actually can carry acids right in the groundwater, which causes the heavy metal problems that we talked about when we talked about acid rain. You've got acid drainage, acid mine drainage. And this is where the water comes in contact with all these ores that you've exposed, and that can leak out of subsurface mines, it can run off of surface mines. And this is actually an example of some of the stuff. This is orange, like orange, that is water, and this is flowing out of this mine. Okay, now when we talk about extraction and processing, when you look at land disturbances, you're talking about habitat destruction and subsidence. We'll come back to the subsidence in a minute. The waste from mines, 40% of the mining area is actually for waste disposal. Remember when we talked about solid waste, most of the solid waste is actually coming from the mining and drilling industries. It's 40% of all solid waste, right? And then there's special mining, and in some cases, you really toxic chemicals are used, and you get chemical leaching from that. And gold mining is a really good example. In developing nations, they actually use cyanide and mercury. And here's a nice little pool of a guy rubbing his hand in mercury. And then here you have this toxic pool here too. None of these are lined, right? And so all of these chemicals that were used in the extraction, the separation, are actually just leaching into the groundwater, and that's bad. And speaking of water, you get all of this leaching in addition to the acid, right? And so you've got two things that are happening. You've got these flooded tunnels for underground mines, right? And then you've got these pools that are filling in these pit mines or surface mines. Okay, and here's just an example of runoff. This is the mine. This is where you've got runoff coming down. It has actually killed off all the vegetation and then started to erode. And then these white streaks are mineral deposits that are actually coming from the tailing. And there could be lots of really toxic things in this. Okay, and here is a really good example of a toxic lake, and this is Berkeley Pit. It's in Butte, Montana, and this water is so toxic. It's acidic and toxic, but it is so toxic that birds that land on it and drink it die, right? And there's nothing that you can do about this. I mean, this is a building right over here. So this is huge. How do you clean that up? So the real point is that you have to prevent it. You can't clean it up once it happens. You have to prevent it from happening. And here is subsidence, right? Here's an old copper mine in Arizona, and you can see the land just fell into it. And then here are little pits, little pits of subsidence in abandoned coal mines, and you can see this is where they've dug through, and everything's starting to drop. But you can see these really nice little regular shapes. Okay, so when we talk about degradation of capital from extracting and processing, you can sum it all up into these environmental effects. And so what this slide does for you is attaches the environmental effects to each step, right? So mining is going to have all this, processing, all of this, and then the use, all of this. And so you want to be familiar with this picture. Okay, so legislation about this. There is actually not a whole lot of legislation. I mean, there is, but not really significant things that we would list in this class. But the one thing that you do want to know is the Surface Mining Control and Reclamation Act. It was established in 1977, and every mine that has opened since 1977 must be restored to pre-mining conditions. And that's been great on a lot of levels. Unfortunately, all of the things that were before 1997, they don't have the same requirements, and there are taxes, but those mining companies have to still be in business, and you have to know who owns the mine. Everybody still has to be alive, right? And so there's all kinds of issues with that. And so ultimately this results in limited success, because you have to think about how many mines are actually opening every day. And there are mines opening on a fairly consistent basis, but it's not going to be lots and lots and lots. So this is not the it's great going forward, but it doesn't really do a whole lot for things that are grandfathered in. All right, so the mining cycle in a nutshell is going to be exploration, right? That means finding it, mining it, and then reclaiming the land so it looks like it did before. Okay, now this brings us to the idea of how do you stop mining so much? Well, recycling. Reduce, reuse, recycle actually applies to all of this, but I want to talk about recycling because a lot of times what you're dealing with is metal, and that's going to prevent you from having to open new mines or continue to get virgin materials. And the most recycled metals actually are iron and steel, and it's about 90% of all iron and steel is recycled, and it's easy to do. You just melt it down, reform it. And it takes about a third of the energy needed to produce steel from recycled scrap, right, from old, previously used iron steel, than from the virgin ore. And what that means is you save a huge amount of money, and about $40 billion was produced from recycled metals in 1998. And I do not have an update on that, but it's going to be a whole lot more now because we recycle a whole lot more than we did, 15 years ago. Other recycled metals include lead, lots of lead recycling, aluminum, just almost 40%, right, and a little bit more well, a little bit more now. These numbers are from a couple of years ago, but aluminum, we'd like to think it was more because of all of the aluminum cans and stuff. And then copper, right? Also pretty good. And copper actually is kind of expensive. People actually steal copper wires out of stuff to collect the money on the deposits. But anyway, so recycling, why do we recycle, right? We recycle because we have to think about what mining does. And these are the things that mining does, right? That's the impact of the waste from mining. So what do? You can save energy, you can save money, you can save land, you can save raw material by recycling, okay? And so that's kind of the bottom line, and it works. Now, let's talk a little bit about the human cost of mining. And we're not talking about, actual mining conditions and things like that. It turns out in the United States, there are strict regulations about safety, mine safety, and safety in the workplace in general. And so that actually is as safe as it possibly can be. Mining is here, but what I really want to talk about is the conflict minerals, okay? And so when we talk about conflict minerals, we're really talking about gold and diamonds. And you probably know conflict diamonds better as blood diamonds. And so here are some pictures of things that go on. But mostly what happens is that the local population is forced labor to mine for either dictators or warlords, and there are all sorts of horrible threats of physical harm and death, right? And the conditions are really, really bad. And so all of the proceeds from this, there's no benefit to the people who live there. They're just used to mine, and most of this money actually goes to fund drug and weapons trafficking, as well as sometimes human trafficking and terrorism. So you want to always be careful about where your gold and diamonds are coming from. But just a little side note on some of the products that we mine. Okay, so if you have any questions about anything in this presentation, please let me know, and I will see you next time. Thanks for listening.